Using the relationships created by interior and exterior angles in a triangle, we can set up solvable equations. This can not only find missing values of x, but help us find the angle represented within a triangle, either an interior or exterior angle. To start, we need to look at the angles inside and outside of a triangle. Interior angles. We know that the sum of all interior angles in a triangle is 180 degrees. So if I add up angle 1, angle 2, and angle 3, I get 180 degrees. In the past, we've been given at least two of those angles in order to find the third. We substitute the two that are given to us, and then we solve for the third. This process can be expanded when algebraic expressions are placed inside of the triangle's angle measures instead of degree measures. Exterior angles occur when you extend a ray outside of the triangle. So it's taking one of the sides or legs of the triangle and extending it out. This creates an angle like angle number 4. It's exterior. It's outside of the triangle. There's a couple relationships we can observe with exterior angles. In this case, we know that angle 3 and angle 4 in this diagram equal 180 degrees. We know that because we've observed that these are supplementary angles, these are linear pairs. We've seen them called adjacent angles when we have parallels cut by a transversal. We've seen this relationship many times. So if we know angle 3, we can automatically find angle 4. If we don't know angle 3, but we know angle 1 and 2, we can solve for angle 4 as well. Because the two interior angles that are not supplementary to the exterior angle add up to create the sum of the exterior angle. So angle 1 plus angle 2 equals angle 4. This is logical because angle 1 and 2 plus 3 makes 180. Angle 4 plus 3 equals 180. They both have to be the same value, 4 and the sum of 1 and 2. If we're given a triangle with both angle measures and algebraic expressions, the process is exactly the same. We need to look at the relationship that's present, substitute values in that represent the individual angles in that relationship or formula, and then solve for what we don't know. It's the same thing we've done. So we're solving for x in this case. We're going to use those interior and exterior angle formulas. So I know that in this case, all three of those interior angles have to add up to 180 degrees. Whether there's variables in there or not, whether I'm given angle measures or expressions, no matter what, it adds up to 180 degrees. I just need to employ some algebra skills in order to solve for my values. So I substitute in the expression, not just angle measures. And then you use multi-step equation skills to solve. So let's try this one. I know that all three of those angles add up to 180 degrees. So I'm going to substitute in for angle 1, 54 degrees. For angle 2, I'll substitute in 3x plus 1. And then for angle 3, I substitute in x minus 9. I set that all equal to 180 degrees. All three angles are represented. 54, 3x plus 1, and x minus 9. Now, I need to treat this as one big multi-step equation. When I do multi-step equations, I need to simplify the expressions on both sides in order to turn it into something I know, like a two-step equation or even a one-step equation. So I'm going to combine all of my variables and constants on the left side. I see 3x and x, that'll give me 4x. I see 54 plus 1 is 55. 55 minus 9 gives us 46. So I have 46 plus 4x equals 180. I simplified that multi-step equation into a two-step equation. In this case, I see that what's happening to my variable is that I'm multiplying by 4 and adding 46. So I need to subtract 46 and divide by 4. So I subtract 46 from both sides. That'll give me 4x on the left because I get my identity. 46 minus 46 cancels out. 180 minus 46 gives me 134. Divide both sides left and right by 4. X is just x, and 134 divided by 4 gives me 33.5. This represents the variable x. This is what x represents. If you're asked to find the angle measure, the first thing you need to do is solve for x, which in this case we've already done. We set up our equation by substituting the algebraic expressions and angle measures into the formula angle 1 plus angle 2 plus angle 3 equals 180. We combined like terms and solved. Once I have my variable solved, I have my solution. I can substitute the solution into the expression and evaluate. Let's say I wanted to find the angle measure for x minus 9. I start by writing out my expression, x minus 9. X equals 33.5, so I'm just going to substitute it in. 33.5 minus 9 gives me 24.5. So that means that that angle has a measurement of 24.5 degrees. I could do the same by taking 3x plus 1 and substituting in 33.5 again. 3 times 33.5 plus 1 gives me 101.5. It means I have an angle measure of 101.5 degrees. If I wanted to check this, I could add up all three of those values, and I should end up with 180 degrees. Let's look at an example triangle together. We have one angle measure that's 15 plus x, one that's 47 degrees, and one that's 18 plus 4x. If the problem simply asks you to solve for x, we're going to use our relationship and solve for x. So I know that this angle, or all these angles, add up to 180 degrees because these are interior angles of a triangle. So I'm going to substitute in all three of my angles, not just the angle measure, so not just the degrees, but if it's represented by an expression, I substitute it in just the same. 15 plus x plus 47 plus 18 plus 4x. All three expressions are represented here, and they're all equal to 180 when they're added up. Now I'm going to treat this like a multi-step equation. Simplify as much as you can. I see x and 4x, that's how I got 5x. 15 plus 47 plus 18 gives me 80. And that still equals 180. This is turned into a two-step equation. I ask myself two questions. What's happening to my variable? How do I undo it? I'm multiplying by 5 and then adding 80. That's what's happening to my variable. So to undo that, I just go backwards. I'm going to subtract 80 from both sides, and then I'm going to divide by 5. X equals 20. Some questions, that's all they're asking for. Others may ask you to solve for the missing angle measure, so the missing degree measure of a particular angle. In this case, if I know what x equals, I can substitute it in. So if I had to find what 15 plus x represents as a degree measure, I substitute 20 in for x. 15 plus 20 gives me 35. That means that 15 plus x could also be represented by 35 degrees. I can do the same with 18 plus 4x. I substitute in my solution, in this case it's 20, and I multiply. 4 times 20 is 80, 80 plus 18 is 98. So this is 98 degrees. If I wanted to check, I can see that 47 plus 35 gives me 82. 82 plus 98 is going to give me 180. So all of my interior angles add up to 180, even though they started with variables and as algebraic expressions. Let's look at another example that involves an exterior angle. Exterior angles can be solved or have two real relationships that they're connected to. One, if the angle directly next to it, the adjacent angle, the supplementary angle, the linear pair, however you want to name it, is present, I can solve for my exterior angle. We don't have that. So instead we have to look at our other relationship. The two interior angles that are not adjacent or not supplementary to the exterior angle add up to equal the exterior angle. So in this case we can think of it as angle 1 plus angle 2 equals angle 4. We just substitute in. Angle 1 is represented by 12 plus 3x, angle 2 is represented by 70, and angle 4, the exterior angle, is represented by 9x plus 4. So now I just need to treat this as a multi-step equation. I might simplify my algebraic expressions on the left side and right side of my equation. So that's going to give me 3x plus 82 equals 9x plus 4. I can only solve this when all of my variables are on one side. I'm going to move the 3x from one side to the other. When I combine like terms across an equal sign, that's the only time I use inverse operations to combine like terms. To move the 3x from left to right, I need to subtract 3x from both sides. 3x minus 3x is 0, leaving me with just 82 on the left. 9x minus 3x gives us 6x, and the 4 just comes straight down. Now we have a two-step equation. I ask myself the same two questions. What's happening to my variable? How do I undo it? I'm multiplying by 6 and adding 4, so I'm going to go in the inverse operation, or go in the inverse direction using inverse operation. So I'm going to subtract 4 from both sides. 82 minus 4 gives me 78. 4 minus 4 gives me 0, my identity. 6x, I need to divide by 6. When I divide 6 by 6, I get 1. When I divide 78 by 6, I get 13. So x equals 13. Some questions, that's all they ask you to do is solve for x. Others may ask you to identify the angle measure or the degree measure of a certain angle. To do that, we substitute in. So if I wanted to find the measurement, the angle measure of 9x plus 4, I could substitute 13 in for x. 9 times 13 plus 4 gives me an angle measure of 122 degrees. So the angle that's represented by the algebraic expression 9x plus 4 has an angle measure of 121 degrees. If instead they asked you to find the angle measure or degree measure of 12 plus 3x, I would use that algebraic expression and substitute in. 12 plus 3 times 13, I get 12 plus 39 gives me 51. So the algebraic expression 12 plus 3x, when x equals 20, represents 51 degrees. If the question then asked you to find the other missing angle, you could either do 180 minus 121, since those two angles, your exterior and your missing interior, are supplementary, you can just subtract from 180. Or you can do 51 plus 70 plus an unknown equals 180, and then just solve for your missing angle measure.